Cognitive Life. Here's your host, Swastigar. I am a CNCF ambassador and a product engineer at Improving. If you don't know, Cognitive Live is a weekly show where we have different presenters from Cognitive community sharing their knowledge and experience. Today we are having Dan from Apple, who is a staff engineer there, and we will be discussing about Pickle. Please keep in mind this is a CNCF affiliated live stream, so be respectful towards each other in the chat. And without further ado, I will hand this over to Dan.
Hey, yeah, like Swastik said, my name is Dan. I work at Apple, and I'm fortunate enough to work on something called Pickle. And that's what I'm here to talk about today. Um, Pickle is, as you'll see, it's a language that's meant for configuration. So it's a programming language that just has one use case that we care about, which is to configure things. And one of the main things that it does is to help people that target big configuration problems. Kubernetes being one of them. And so that's what we've done. We worked on Pickle for a long time at Apple, and we've just recently open sourced it about a year and a half ago. And as with open sourcing, this is something that we really love people to get involved in and contribute to and start using it. And that's kind of what I'm hoping to share and to inspire people to do. I'm hoping that people can take a look at this and try to apply this to their own problems and projects. So first, I'm going to go ahead and I'll go ahead and share my screen. Share screen, share entire screen. Do you see my screen?
Yeah, it's visible.
Yeah. Okay, great. So here is our website. This is pickle-laying.org. And this kind of gives you a brief overview for what Pickle is. Pickle is a programming language. So our tagline is configuration that is programmable, scalable, and safe. And these are the three things that we want to really demonstrate and solve by creating Pickle, the language. So one of the things that you do with Pickle is you take a Pickle program and you take the Pickle evaluator and you evaluate the program, you produce output. And one of the ways you produce output is you produce text. So here's an example. Here is a lovely Pickle program called bird.pickle. And this has a name and it has a job. And then you can take Pickle and you can render this into different configuration outputs. So here's an example. Here's bird.pickle and here's bird.json. And here's bird.yaml. Looks very similar. Bird.plist, bird.properties, and also more. You can take Pickle and render to any configuration format that you want. Pickle, the language, has built-in renderers for these formats, and it also has the ability for you to define your own renderer. For example, there is a TOML renderer for Pickle as well, and that's written inside the language. One of the things you can also do with Pickle is use it as a library. So it's not just a language that evals and spits out text. It's a library that can pull into a program. Like if you're writing in Go or in Swift or Java, Kotlin, you can use Pickle, pull it down from Maven, from whatever the correct way for managing dependencies is, and then you have this library available to you. And what you do with Pickle is you can call into Pickle, and you can use Pickle as the source for config, and not only for the source for data, but you can use it as the source of truth for the shape of your config, for the schema of your config. For example, here's my app config, and this has a property called host, except notice we have colon here. So this is host that has a type. So this says this configuration object has a property called host that is of type string. It has a property called port that is of type uint16, where this is greater than 1000. And then you code gen that. So here's what Java might look like. It's the same thing, but it has Java. There's a Java class that was code generated from Pickle, et cetera, et cetera. Here's Kotlin, Swift, and Go. And then, like with configuration formats, this can also be extended. So we maintain these 4 language bindings, but our community has also implemented language bindings for pretty much all the popular languages out there. And that includes TypeScript, Python, Ruby, Rust, and probably more that I'm missing. That's kind of a high-level overview. As part of what we do, part of what we think is the language is only as good as the editor support for writing things in that language. And so we put a lot of focus into making the editing experience rich and meaningful and a joy to use. And so we have plugins for VS Code and IntelliJ and NeoVim, and then we also have a language server. So if you have another language, if you have another editor that you like, as long as it supports the LSP, you can add Pickle support to it. So that's kind of the overview of Pickle. And actually what I want to do for most of this stream is I want to show what it's like to write Pickle. I feel like that's one of the best ways to learn a language. You can only learn so much just by reading the documentation or just looking at the landing page. But I want to show you what it's like to write Pickle. And my hope is this is kind of gonna show you what Pickle is and how it's useful and how you can apply it to your own projects. So in front of me, I have IntelliJ open. And inside IntelliJ, I have a blank file and I have the Pickle plugin installed. My demo is going to be in 5 parts, and then within every part, I think I'll kind of pause and see if there's any questions about this. So here's a blank file, and this file itself is an object. So you can kind of think of every Pickle program, every file, as an object. Kind of, if you're thinking about this in JSON terms, there is kind of an implicit opening curly brace and an implicit closing curly brace delimiting the document. And inside here, we can add properties. So foo equals 1, for example, or bar equals foo. And now here's my program. I'm going to go ahead and cd into part 0, and I will pickle eval tor.pickle. Pickle is the CLI that I've installed. You can install it through Homebrew. You can install it through a bunch of other means. So I've evaled the tor.pickle program, and this is the output. The output is foo equals 1, bar equals 1. And like I said earlier, Pickle can eval into textual output. This is what this is doing. And this is the program as a format called PCF. This is basically Pickle without types. I can eval this into JSON. I can eval this into YAML and plist and a bunch of other stuff. So really what this means is if you have some external format that doesn't know about Pickle, it can't understand Pickle, that's okay because Pickle can eval into the format that thing understands. So Pickle's an object. So this is an object, right? We can have some nested objects. Nested prop equals foo. And here we go. And again, I'm going to eval this into JSON. And here's my lovely JSON. Foo is 1, bar is 1, nested prop equals 1. And one of the things that we try to do is we want to make Pickle easy to read and easy and for this to kind of mimic the target language that you're configuring. But at the same time, Pickle is generic enough to represent different configuration formats. So that's the end of part 0. Quick tour, but we're gonna get into more details here and get into pretty advanced use cases. So before I move on, are there any are there any questions about part 0 so far, or about Pickle, or what I've talked about?
Uh, if you guys have any questions, you can just drop them in the chats, and yeah. Currently, I don't see any questions, but if any case any of you have any doubts or questions in between the chats, please free to post them. Since the live stream is actually delayed by a couple of minutes.
Oh, it's delayed by a couple of minutes.
Yeah.
Well, feel free to interrupt me, I guess, or maybe just group them
Yeah.
into the next after the next
Yeah.
part.
Sure. Yeah.
Okay, so now I want to show what it might be like to use Pickle for infrastructure as code. So I'm going to go ahead and close that. And here's the next part. So infrastructure as code typically looks something like this, right? Like you have you have code which is YAML, and then you take this file and you apply it to a system, and the system takes you declared YAML, and then proof it creates the stuff that you want. And here's an example of infrastructure. This is very simple. Here is something that declares I'm on 2 machines. By the way, this is not real. This is not a real system. This is just a made up thing that for demonstration purposes. So here's my infrastructure as code YAML that says I want 2 machines. I want a machine in US West. I want a machine in US East. And then here's all the properties of each machine. And so how will we take Pickle and use it in place of this YAML? In Pickle, one of the concepts here is you first want to define the type. You want to define the type that represents the target system. And then once you have the type, you define the data. So that's what we're going to do. We're going to first define the type. And here I'm going to call it foobar system. And we're going to go ahead and start filling out what the type of this IOC system looks like. So here's our YAML. Our YAML has a top-level property called machines. And this is a YAML sequence. This YAML sequence has a bunch of objects. And in Pickle, we'll say this is a listing. And what is this a listing of? This is a listing of machine. And already my editor starts yelling at me because it doesn't know what machine is. If I hover over this, it says, oh, I don't know what machine is. And indeed, we haven't told it what machine means. So here we go, class machine. So this represents the inner object. So machine represents this guy. And so what is this guy? So this is also something that has properties. It has a region, and this is a string. Except, well, let's go ahead and improve on this a little bit. So let's say US West, US East. Let's say this is a closed set of regions because we're not going to have US deep north, for example, US Southwest within Atlanta. Like that's not a region. Southeast, I guess. So what we could do is we can say this is of type the US West string literal or the US East string literal. Moving on. So environment. Environment is here. This is an open. This is arbitrary key value pairs, where each key is a string, each value is a string. In another language, you might say this is a map. In Pickle, you would say this is a map, or you might say it's a dictionary. In Pickle, you would say this is a mapping of string to string. Moving on, we have CPUs. CPUs is 4. So this is a number. So here we'll say this is an int in Pickle. Except CPUs -4 might not make sense. CPUs 10 million might blow up your system. So what you can do is you can say this is a uint, or we could say this is a uint8, or this is between 1 and 32. Because let's imagine that we don't have any machines with more than 32 CPUs. If you try to give it more, then that's not valid configuration, right? Then we have memory. Memory here is 4GI, and this is a string. In Pickle, we could do a little better than that. So memory is a data size. So instead of trying to figure out what is the correct syntax for describing a data size for this particular target, you can define this as simply data size type in Pickle, and then when you're defining the data, you don't need to worry about, oh, how do I correctly formulate what 4 gigabits means. Then we have health checks. So health checks is, again, this is a YAML sequence. So we will go ahead and say this is yet again, a listing of health check. And once again, my editor is yelling at me because it doesn't know what health check is. And indeed, it should not know because I did not tell it what it is. But now, here we go. This has a blast through this really quickly. So it has a port, which is a uint16. That makes sense because ports cannot be less than 0. It cannot be over than the max uint16. Has type. And again, we can say this is either the type TCP or HTTP, for example, because maybe the health checker doesn't know what another type of health check is. We can constrain it, and then if you give it a wrong value, then the editor will yell at you. The Pickle program will fail to eval. And then the interval, and in YAML we have 5. What is 5? Is that 5 seconds, nanoseconds, hours? If I'm describing this, if I'm a user of this, I might not know exactly what 5 means. In Pickle, there's also a built-in type for duration, and so you don't need to worry about what is the time unit here, because the type itself tells us this is a duration type. You need to give us exactly what the duration is. And so here's our template. And I'm going to go ahead and jump into, so this is typically what you do. You define the template. The template really just means the type for the data that you're describing. And typically you want to take your time and document the template and make sure this is well typed, so that if you provide incorrect data, that Pickle will error, and then you'll get an error within your at diff time. So the whole concept of shifting errors left, moving errors to local, so you don't discover these as you deploy this to Kubernetes or somewhere else, and then take that on your system. And here's an example. So I've kind of taken my time outside of like before this, and I fleshed out what a rich definition could look like. I've added doc comments. And so here I have, as I hover over this, my editor will also tell me this is what this property means. And I'm going to go ahead and copy and paste this into here. And now that I have my my schema, my template, I could go ahead and define the data for it. One of the analogies that we like to use is when you define your schema, you're kind of defining a form to fill out. And then when you're defining the data, you're filling in the form. And the keyword here, I have another module that has this keyword, immense foobar system. This means this module adheres to foobar system. It is like foobar system with this extra stuff. And now Pickle's going to put me on Rails. So if I say foo equals 5, Pickle's going to say, I don't know what foo is. I can only define properties on foobar system, so this is an error. So now we're just creating, basically, you could kind of think of this as we have defined a class, and now we're creating an instance of the class. Now we're going to go ahead and copy and mimic the data that we have on the right-hand side. So we have machines, and within machines, we have 2 machines. And we have 2 objects. So we're going to create the first object. That's what this new keyword is doing. And the region is US West. And notice that the editor auto-completes this for me. And then we have env with, and this is, again, this is key value pairs. This is a mapping. And when you add things to a mapping, you need to use mapping syntax. This is what that looks like. And I'm going to go ahead and copy and paste this into here. And we can blast through this kind of quickly. Then we have CPUs is 4, memory is 4 GIB. Health checks, there is 1 health check. The port is 4050, type is TCP, and the interval is 5 seconds. So this is the first machine, and I'll go ahead and come into the shell, and I will eval this. Pickle eval myconfig.pickle, and this spits out. Let me go ahead and show this with syntax highlighting. So this is what the YAML looks like, and it's almost exactly the same as the thing on the right-hand side, except there's 2 of them. So let's go ahead and fix that. So there's 2 machines. Was one US West, is one in US East. So here we go. Now we have 2 machines. I've just copy and pasted a lot of stuff, and I changed the region to US East, and then the HTTP proxy is also different. And I can go ahead and eval that, and now I get exactly the same YAML. Or more specifically, I get the same semantic YAML that I have on the right-hand side. So as a user, what I would do is I would take Pickle, eval this, and then I would pass that to the system that takes YAML. So Pickle isn't just this thing that has this, fill out the form. Here's the form, you fill out the form. It's also a language that has a lot of expressivity built in. And I kind of alluded to this earlier. I just did a lot of copy and pasting. Most of this is the same between these 2 machines. So what I can do is I can create a base object and then share things. And I'll go ahead and show what that looks like. So I'm going to create a base machine. And I'm going to go ahead and, and copy and paste the first object, except the region is different between these 2 machines, right? And the environment is also different between these 2 machines. So I'm going to go ahead and get rid of region. Also, notice that the environment uses the region. So I'm going to say the environment is outer.region.mycompany.com. And now I'm going to amend this base machine. So the first machine is like base machine, except the region is US West. And then the second machine is also like base machine, except the region is US East. And I can go ahead and eval that. Go ahead and pull that up. And I get more or less the same thing. Actually, I get exactly the same thing, not more or less. Now, this is one way that you can simplify your code. You can take common things and group them together, create a base object that you then use downstream. You can also do things like, I want to create a machine for every region, and that comes from some sort of list. So I can use a for generator. For machine in list US West, US East, create a machine where the region, for region in US West, US East, create a machine where the region is that region. And then as I hover over region, we see Pickle understands, oh, the region is of type either US West or US East. So it kind of inferred that for you. And then with that, we can eval this again, and this gives us, pull this up. Again, exactly the same YAML. And this is already more maintainable because let's say we come along and we want to add another region, US South. Let's see, it doesn't like it because it needs to be, oh, US South is not a thing. It needs to be one of these. Okay, great. So EU West. Okay, now that error went away. And now if I eval this, I get 3 machines instead of 2. So this is part 1. Quick deep dive into the basics of writing config in Pickle. So do we have any questions about this so far?
Yeah, we have a question from Lewis.
Yep.
If possible, later on to link this, how can we use Pickle with Maven and Nexus? How to define our own library to publish then and consume them?
Yeah, great question. I'll get into this pretty soon, actually. So Pickle is a language that has a packaging system, so you can create packages, publish them to the internet, to anywhere that you want, and then you can pull it down as a dependency. And then when you publish a package, that package will depend on other packages, and the Pickle will resolve versions and all that normal, all the good stuff, all the normal languagey stuff. Any other questions?
Hopefully that resolves your question, Lewis. The question is like actually from my side.
Yep.
So I like correct me if I'm wrong. These are like internally PKL is like parsers, which like tokenizes your PKL file and then maps them using like parse trees to your like YAML or JSON, right? Uh, and so is there any like parser that similar parser that converts YAML to PKL?
Yeah, so it's a little more, you're kind of on the right track. It's a little more than that. Pickle is an interpreted language. So underneath the
Yeah.
hood, the evaluator will parse the Pickle program and turn those into machine instructions. And those instructions then turn your Pickle program into JSON, YAML, or anything else. And we do have tooling that migrates YAML or JSON or other things into Pickle as well. For example, we have a library that converts Kubernetes YAML into Pickle. So that's a command that you can run pickle eval convert this converter, and you pass in the YAML program as an input, and it spits out pickle for you.
Yep, that answers my question. Thanks.
All right, great. Now is part 2. Now we're going to go into a more real world situation. And I want to show you what it might be like for you to use Pickle to configure a Prometheus deployment in Kubernetes. So we'll use this as an example. Prometheus, if you're not aware, is a tool for gathering metrics and processing and alerting. And does a bunch of stuff. One of the things that Prometheus does is it provides something called a scraper. You deploy the scraper to Kubernetes, and then you configure the scraper to say, hey, scrape this stuff and send these metrics to this location. And so here I have part 2 with 3 files. And the first thing is I have a file called Pickle project. A project allows me to declare dependencies, and this kind of goes to Lewis's question earlier. I've pulled in these dependencies that are published to the internet, declared them, and now I can use these as libraries inside Pickle. So I have a dependency on Kubernetes. I have a dependency on Prometheus. And here is something that I've called Prometheus deployment. And I've imported the Kubernetes deployment library, config map, and all this stuff. And then I can navigate to these to the sources here. So here's deployment.pickle. This is the library to configure a Kubernetes apps v1 deployment. And I also have the library for a Prometheus configuration. This is what that looks like. And if you are familiar with Prometheus, this might look familiar to you. I have things like global alerting, scrape configs, etc., etc. And now I have a template. I have something where I'm describing the types for my downstream users to fill out. And this is what the types look like. I have a top level property called Prometheus that is of type configuration. Its type is a Prometheus configuration. And then I've created a config map where the config map has a prometheus.conf entry, and the value is the rendered output, the textual rendered output of the Prometheus configuration. If you've deployed Prometheus before, this might look familiar. This is one of the ways you can do it. You create a Kubernetes deployment, and in a Kubernetes config map, you mount the config map as a volume, and then you deploy the Prometheus image, and then you tell the image, here's the prometheus.conf that I want you to use for your scraper. And so that's what this is mostly doing. It's mounting a deployment. It creates a container with the Prometheus image, and it mounts the config map as a volume. And notice here, my output eventually is the Kubernetes config map and deployment. But the form that I'm providing to users to fill out is just tell me what the prometheus.conf is. So what I'm doing here is I'm creating an abstraction. This is an abstraction for a config map. What results in a config map and a deployment. And the API of this thing is just the Prometheus configuration. And I will go ahead and show what it's like to fill this out. So here we go. Again, we have a file that amends Prometheus deployment, and now we're just providing the data. And as we inspect the API, okay, I'm the user. What do I need to do? I have Prometheus to fill out. Okay. So here we go. So we want to create some scrape configs, and we want to scrape Kubernetes, and we want to, let's see, we want to scrape the namespaces of foo. Now I can go ahead and I'm going to clear this CD into part 2. And I'm going to eval this. And we have an error. So let's see what happened. I'm going to not do that because I don't get colors. So we have an error. The job name, I forgot to define the job name. Okay, cool. So this was the first scrape config's job name. So the first scrape config needs a job name. The job name is foo. Okay, here we go. We fix the error. And now that we've rendered this, that we've defined this correctly, here are the underlying resources that I can now apply to my cluster. So I kind of want to call out 2 things here. One is Pickle has bindings for external libraries that you can just use, and you can use as an API within Pickle. So what this might look like for a lot of things when you're configuring something is you might have to pull up a website and have it side by side and know what the types are, so you can know how to use them. We use Pickle and you create rich templates, rich types and documentation for them. This is now a Pickle API, and you're creating a Pickle object. So you just need to conform to Pickle, and you're only thinking in Pickle. You don't need to worry about pulling up, the documentation what that might look like. Another thing I want to call out is if you were doing this and you were just writing YAML, within YAML you'd be defining the Prometheus.conf as a string. You would say Prometheus.conf : and you'd be writing something like this: Prometheus.conf is a multi-line string where the string value is this. And now you're kind of in you're in you're explore your own, you choose your own adventure territory, because as far as the editor knows, it doesn't know that this is a Prometheus.conf. It doesn't even know this is YAML, right? It just knows this is a string, and you can have incorrect YAML in here. It's not going to help you. But because I've imported everything into Pickle, and I'm defining this as just Pickle structures, the moment I do anything wrong, Pickle itself will let me know, hey, this is incorrect. And I can easily pass the rendered output of Prometheus into the config map, and that's just because that's part of what Pickle can do for you. And that's part 2. Are there any questions about part 2?
No, I don't see any questions. So I guess we can move on to the next part. And also, heads up, only like 20 minutes are remaining. So try to wrap this up as soon as possible.
All right, sounds good. All right, I'll speed it up a little bit. So part 3 kind of builds upon part 2. Part 3 is an example of what it might look like to use Pickle in a large Kubernetes cluster, or so a large Kubernetes deployment. With Kubernetes, typically you don't just deploy things to one cluster, because you want things like failover, you want resilient deployments. So you might deploy things to staging and then promote it to production. And then you might also have multiple clusters running. You might have a cluster running in US East, US West. And that's what we have here. So we have part 3 is imagine this as the root of the repo. And then within here, we have production and staging. These are the environments that we have. And then within each environment, we have US East and US West. And now I have a Prometheus.pickle that looks very similar to what I just showed you in part 2. So I have this. Here is the thing that you'd fill out when you want to create a Prometheus scraper. This is the configuration that I want you to fill out. And here are the defaults. This is the base things that we're going to apply to every Prometheus. And I've taken the liberty to add a little more controls here. So here's the resource requirements that we are going to define. And here are more things that even more things that we can add. And then eventually here's the actual Kubernetes output. I'm going to create the deployment and I'm going to create the config map. And now what we can do is we can say, I want to deploy a Prometheus.pickle. I wanted to deploy Prometheus to production in US East. So what you do here is, again, use the keyword amend. So you say this is a object just like my parent object. And this is amend ... just means it amends the same, an object with the same file name further up the tree. So here it amends ... which as you if kind of look in the Explorer, so first it was here and now we're in, so this jumped to here, which means this object amends this guy. And this object also amends ... and that amends this guy. So this is an object that builds upon this, which is an object that builds upon this. What this means is we can deploy Prometheus and change something specific to how we're deploying to US East just by changing the values within this file right here, production/US East. In this specifically, we are deploying version 10. And elsewhere, we're deploying version something else. And let's say for all of production, we want our production containers to run with certain resources. If I want to change everything, because say for as a reminder, this amends this. So this guy's parent is this guy. So if I change any value within production/Prometheus, I am changing both of these. So let's say I want to change the resource requirements to have 10 CPUs and 8 gigabits. I can go into here, make that change, and now I've changed it for all of production. So this is an example. This is one of the ways that you can manage complexity within Pickle. So another example is, okay, let's say we want to deploy Prometheus version 10 everywhere in production. Well, I can go ahead and move that to here. And now I've changed it everywhere, and now this is redundant. And I've deployed, and now I've affected the data that I'm using for production. And if I wanted to do something for staging, well, I can easily come to staging and also create a Prometheus.pickle within staging and manage things that way. Now I'm going to go ahead and cd into part 3, pickle eval. And now I'm going to use the pickle CLI, pickle eval production/US East /Prometheus.pickle. And here is, again, something more or less the same thing, except let me go ahead and show this as YAML. So here is the config map. Here's the deployment, and here's the things that we've configured for production specifically. Pickle is it's a very powerful language. This is a very powerful tool. So if you kind of imagine, if you keep following this pattern, I can create another thing that I deploy. So here I have Prometheus, but maybe I also want to deploy Redis, so I can create a Redis.pickle or Jenkins.pickle or anything else like my bespoke application.pickle, and I can define here are the knobs that my application needs or that Jenkins needs or etc. And then here's the output. It produces Kubernetes. Here's the actual stuff that it creates. This might kind of seem similar to like if you are maybe using Helm, for example, then you might use a Helm chart for Prometheus, and that would have a values dot YAML, and instead of having it like a just a one-off file, and then the rest of it is kind of a black box to me. This is all stuff in the language itself. These aren't just objects. These are just regular objects in the language. So that's kind of that's kind of the end for part 3. Are there any questions about part 3?
Yeah, we have a question from Louis again.
Mm-hmm.
How would one use Pickle with Argo CD? For example, the generate YAML needs to be committed into Git.
Mm-hmm. How would you use CD with CI/CD
Yeah,
or with
from example, the generated YAML needs to be committed into Git.
so often what people they use direct manifest pattern. So you eval the pickle into YAML, and then you also YAML as part or like you write a bunch of pickle that also gets so have it you also have an easy if what that or it gets applied to Kubernetes. That's up to you. Like pickle itself doesn't care, but that's a pretty common pattern.
I hope that answers your question, Liz. If there are
Okay.
no questions, we can actually move forward.
Yep. Say we got 10, 30 left.
Yep.
Okay. So
Your screen, Dan, your voice and screen is actually lagging. So can you come a bit closer if that's possible? Or is it like sit
my
or fall
is
down?
my sorry request. Um, do you want me to speak up or what?
Yeah, that's fine. No, that's fine. That's good.
This is fine. Okay. Okay. So now we're going to jump into what it might look like as an application that uses Pickle as a library. Earlier, I showed on the website that you can use Pickle and use it within Java, within Swift, and in a bunch of other languages. And so here we're going to show what it look like in Java. If you're a Java developer, this would be the root of a repo, and this might look quite familiar to you. We have a build.gradle, and within the build.gradle, I've pulled in the Pickle plugin, and I've also pulled in the Pickle library as a dependency. And then within our build.gradle, I also have I'm using the Pickle plugin to create a Java code generator that takes the app config source file and it generates that into Java code. And here is the file that I referenced in my build.gradle. Again, this is a type that I've defined. This is itself, kind of think of this as a class. And this has a host, it has a port, and it has a bunch of database connections. And then go ahead and clear CD part 4. I can run Gradle w W config classes. By the way, this is not necessary. This is automatically hooked into as part of Java compile. But I can run the task called config classes, and that generates a bunch of Java for me. And we can see that here. So here's the generated Java app config that was generated from Pickle. And then within my application code, I can use the Pickle library. So here I've imported the Pickle config evaluator. And here is my application code. I have a main method that loads the app config. And within here, I'm using the evaluator API to evaluate appconfig.pickle as an appconfig class. So this turns the pickle into the generated Java class. And now that evals, and at the end of the call, I have an object of type appconfig. And now I can run the rest of my program. So now that I've eval this, I can call .host and .port on the appconfig. Notice what we've done here is we've treated Pickle as the source of truth for the shape of data. And then because we've done that, we have type-safe access within Java and within any language that we support, and within a bunch of languages that our community supports, that our community has created bindings for. So we don't need to guess what the name of the property is. We don't need to guess what the type is either, because host here is a string and port here is an int. So now I have safe access. And also, as part of running this program, Pickle will eval this file, this appconfig.pickle file, verify that this validates before it returns and gives me this appconfig class. And if I give it incorrect data, then I can discover that easily at runtime, and my application will not blow up on me just simply by evaluating the pickle. So here's our Java code, and I can go ahead and run this. And now it says it's listening, except it's not actually listening. But yeah, so this is a very simple example of what it would look like to use Java. It's listening to localhost 10105, and that comes from here, localhost 10105. So that's it. There's a lot of ways you can use Pickle. This is really just scratching the surface, but there's all sorts of stuff that people do with it. It's a really rich language. It allows you to express a lot of complexity, and it has a lot of tools for you to catch errors and make things simpler for you. We like to think of Pickle as the one place to manage all the complexity of your configuration, and for you to use that to target all sorts of things. So for example, here I have my app config in Pickle that targets service configuration. And I can also use it for Kubernetes. I can have the same source of truth for my runtime application and for my static config for infrastructure. And that can all share the same types and schemas too. So I can synchronize everything. I can have Pickle be the one thing that describes my configuration. Everything can just draw from it. I'm going to really quickly jump into this page. This is the package doc site for the packages that we maintain for Pickle. And these are just things that we maintain, but our community also maintains a bunch of code. They publish their own packages, and you can also create your own packages easily and publish them anywhere on the internet. And that's it. That's all I have to share. So, any questions?
That's great. Yeah, Yeah, we are having a couple of questions.
Okay.
Chase Lee is asking, are there any static type of static analysis tools that work with Pickle and things that validate things like schema types, etc. during build time?
Yeah. So I mean, Pickle validates data that's defined in Pickle. Um, when you create a type, you when you create a like class for create an instance of a class, when you eval that object, Pickle's going to validate that before it gives you any data. I think another question here is, can you use Pickle without YAML for external data? And the answer to that is yes, you can. You can write a Pickle program that consumes external data, converts it into the Pickle types, and then validate that. Uh, to be to be frank, that's not a very pleasant experience right now, because when you get the validation, you're going to get validation about Pickle data. It's not going to tell you here's the location YAML that's incorrect, and so that's something that we prove in Pickle.
Okay, hope that answers your question, Chase. We have another question. Why should users choose Pickle over a static format like YAML? Uh, a full-fledged language like TypeScript or another configuration as a code language.
So I hope that I've already demonstrated why you would want Pickle over something like YAML. Um, like YAML can only take you so far, and once you get to scale and you start copying paste around, YAML itself is going to start to feel pretty hard, and that's why a lot of tools exist out there, um, that are meant for managing YAML. Um, for why Pickle over like something like Pulumi, some other language, or Helm or my um, one answer for that is Pickle. I just to just to compare Pickle to like stream templating, for example. Um, Stream templating only understands string, and it doesn't understand anything about the underlying YAML or the JSON or whatever. And I think that type of experience can be a little hard for you to maintain both as an author and because it's a little brittle. It doesn't understand anything about the data structure that you're describing. It's just strings. Um, as for why would you use Pickle versus a general purpose language? So a general purpose language is not geared. It's not meant to solve the problem that we are specifically trying to solve. For example, wouldn't have a type that says this is a number in between zero. And that's just a type in Pickle. You could just say this is the number between enter, throw the language will say, hey, wrong. Um, you can turn JSON schema, for example, type and Pickle back into JSON schema. Uh, it's also like this one app that you can use to configure everything. Like you can use that as a library in your lightweight for you to want to do that. But if you wanted to bring along, JavaScript or bring along Java Go, that's heavyweight, and then that might not make sense as the one format for you to define all your configuration in.
Okay, that makes sense. So we are approaching the end of our stream. So thanks, Dan, for giving us your precious time and explaining us about the Pickle project. And thank you everyone for joining this live stream. Uh, and we will see you soon in the next Love Native Live.